Hi, I'm going to talk today about anomalous activity in the Bitcoin blockchain. The problem that we're trying to solve is to use machine learning to detect patterns that might relate to fraud or other cyber activity on the blockchain. The concept for this is really to be able to visually summarize the large data set that is the Bitcoin blockchain and to be able to drill down into things that look funny in order to more closely examine suspect blocks or transactions. To do this, we want to take a machine learning approach where we begin by actually examining the properties that make up these to look at what's normal and what's potentially out of range so that we can flag something suspect. A bit about me: I'm an electrical engineer with a background in signal processing. I've been interested in this in some time, and so this blockchain challenge has been a great opportunity to actually dig into this and become familiar with some of the tools. Uh, the blockchain, the Bitcoin blockchain that we're working with for this project is the biggest blockchain available, over 500,000 blocks, hundreds of millions of transactions, and truly a big data set of over 100 gigabytes. Uh, in order to work with this, uh, we've deployed a BlockSci tool, which is a blockchain analysis library for Python out of Princeton on Amazon Web Services. I want to talk about the results of this. You can see the code on the GitHub repo. What we've got here are looking first at blocks. So of the 500,000 blocks, what types of features can we extract from them? Well, we can look at how many transactions there were. We can look at the value of the transactions. We can look at how many discrete Bitcoin addresses were involved and what was their ratio. So that's the bottom one. We can look at how many addresses were used in rapid succession, so flags for different kinds of activity. Looking at these, you can see, especially in some of the bottom ones, you can see relative stability with a few spikes, and then you see a couple of big spikes, and those correspond to some big anomalous event. In the case of the mid 2015 spike, we know there was an attack on the network. So these characteristics can flag uh, uh, potentially suspicious activity. Another way to look at this, if we've got some of these features of the blocks and we plot them against one another, we can see clusters, so each point representing one block where they're pretty similar and there's no reason to think anything is out of line with anything else. And then we've got outliers away from the clusters where we say, hey, something different's going on. So you can see in a couple of these plots a few different features, and just circled in red are some outliers that an operator could then look into and say, hey, why is this transaction so out of line with everything else, or this block rather. We can do the same thing with transactions. Um, Transactions again have a number of properties: how many fees were paid, how many addresses, inputs and outputs were involved, how big was the transaction, both in value and in bytes, so how much data was involved in it. And again, we can plot some of that data and we can look for outliers. Some of these points around here, why are they so different from the big clusters here, and is there something to it that we need to look into further? Uh, this is another example showing outliers where again we've got a couple of features plotted against each other. We see a few points that don't fit in with the norm. We drill down into one of them that shows the one circle in red, and it turns out that's actually a transaction where a large amount of money was transacted in such a way that it consolidated from 250 separate addresses. So that's the kind of thing. Maybe there's a reason for it, but it's also a flag for, hey, let's look closer at the addresses involved in this transaction. Maybe there's something weird going on, right? So the next steps with this, uh, there's a lot of automation that can take place now that we've got some feature extraction. We can automatically detect outliers. A big thing is we wanted to start with some of the most basic features. We can go on to a more complicated set of features. So, for example, links between transactions or something a little more detailed. And then to actually compare some of what comes out of this with things that we know were public safety events or something like that. So, in conclusion, we've shown a method for looking at what's normal and then flagging things that aren't normal on the Bitcoin blockchain at the block and the transaction level. A hardware and software platform has been configured that supports this analysis. And this is really a proof of concept for what ultimately I want to become a Tableau, an analysis tool for blockchain where we can zoom in, drill down into suspicious activity for further investigation. Thank you very much.